So let's talk about solving trig equations. The process is very similar to solving regular equations, whether we're factoring or not factoring or not. So if you're looking at example 1a, we have 2x minus 1 equals 0. We're still going to add 1 and divide by 2 to get x is equal to 1/2. Now, example 1b, we're going to follow the exact same steps, except we're going to be replacing x with just the sine of theta. So our first step is still going to be to simply add 1. Next, we're still going to divide by 2. So that when we solve for theta, we're going to look at what angles has a sine of 1/2. So that's bringing into play our arc sine or inverse sine. So we should have an answer of pi over 6 and 5 pi over 6. Notice here we are looking at a range or from 0 to 2 pi. So there are no restrictions. So you're going to have to be careful to read your instructions to determine if you're solving with the restrictions of the inverse or is the interval 0 to 2 pi. Okay? So if we move on to example 2a, notice again, we're going to subtract 2x and get negative x equals negative square root of 3. Divide by negative 1, we get x is equal to the square root of 3. Now you could have subtracted x and added the square root of 3 and had gotten the same answer. But again, for example 2b, we're replacing x with the tangent of theta. So first step, same thing. We're going to end up having negative tangent of theta equal to negative square root of 3 dividing by the negative 1. We get tangent is equal to the square root of 3. So we're thinking about what angles in radians has a tangent of the square root of 3. So we get pi over 3 and 4 pi over 3. So take a moment, pause the video, and see if you can do example 3a and 3b on your own. So for 3a, you should have gotten x to be the square root of 3 over 2. So again, replacing x with the cosine of theta, and then looking at what angles of theta gives us a ratio of the square root of 3 over 2. We should find that we get pi over 6 and 11 pi over 6. Again, we're looking at an interval between 0, including 0, to 2 pi, not including 2 pi. All right, let's move on to the other side. Again, if you need to pause or rewind the video, please feel free to do so. So if we look at example 4a, notice we are adding 4 to get 3x squared equals 1. Divide by 3, x squared is equal to 1/3. Then we have to take the square root of both sides and rationalize. So we end up with plus or minus the square root of 3 over 3. So again, replacing x with the tangent of theta, which makes tangent squared. We're going to look at what angles gives us a ratio of the square root of 3 over 3 in radians between 0 and 2 pi. So working, you should get all of the angles in the pi over 6 family because it is plus or minus. So example 5 is a little different because you have to factor. So 2x squared minus x minus 1 equals 0. So we have to factor that. And we get the two factors, 2x plus 1 and x minus 1. So then we're going to set both of those equal to 0 and solve. So we're going to end up getting x equal to negative 1/2 and x is equal to negative 1. So still replacing x with the cosine of theta. So when we factor it, we end up with those two factors, 2 cosine theta plus 1 and cosine theta minus 1, and then we solve. Notice I'm just replacing x with the cosine of theta. So as you do these, if you want to replace the trig functions with x and then go back and forth, that's fine ultimately as long as you understand what you're ultimately looking for. So in this case, we're going to have 3 solutions. What angles gives us a cosine of negative 1/2? So those two are going to be 2 pi over 3 and 4 pi over 3. And what angle gives us a cosine of 1? That is just going to be 0. Alrighty. So pause the video right now, try example 6 on your own, and then we'll check our work. So as we do example 6a, we subtract 1 to get 4x squared equals 3. Divide by 4 to get x squared equals 3/4. Then we're going to take the square root of both sides. So we have the square root of 3 over the square root of 4. And we cannot forget our plus or minus. So x is equal to plus or minus the square root of 3 over 2. So when we solve for 6b, replacing, so 4 sine squared theta is going to be equal to 3. We're going to divide by 4. And still take the square root of both sides to end up with sine theta equal to plus or minus the square root of 3 over 2. So what angles are going to give us that ratio? Because it's plus or minus, we know we're going to have an entire family. So there we are. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Again, if you need to pause and go back, that is fine. I encourage you to do so. So as you look at the practice, worksheet 1, 2 things I need you to notice. 1, part 1, you are indeed using the restrictions. So that's going to be sine restricted to 1 and 4, tangent restricted to 1 and 4, and cosine restricted to 1 and 2. However, with part 2, that is open. So that is from 0 to 2 pi. There are no restrictions. So make sure you are reading your instructions carefully and working appropriately. So go through the notes, go through the practice, check all of our platforms for answer keys. And we'll talk the next time I see you.